რომ მოიწეროთ, გვაინტერესებს რამდენს გაქვთ წაკითხული დადგენილებას 354-ე. თუ გაქვთ უკვე შესწავლილი, თუ ხართ პირველად ტრენინგზე, თუ უკვე ყოფილ ხართ, ყველამ რაღაც მოიწეროთ. დავით, კითხვა აქვს? დიახ, დავით. დავით ჯი, თქვენ გაქვთ ხელი აწეული, კითხვა გაქვთ თუ შემთხვევით დაგეჯერათ? ალბათ შემთხვევითობა იყო. გთხოვთ მოიწეროთ ჩატში პირველად ტრენინგზე ხართ თუ არა და თუ გაქვთ 354 დღენება წაკითხული. Simon, please, you can start.
Yeah, thank you very much. Happy to have here the second workshop in that row. Last time we concentrated a bit more on the minimum energy performance requirements and the resolution 354 itself. And today we want to do together a little calculation of a not too complex building. It's a university building, a school building, but just to go together through the process how to actually do a calculation. For those who have been already in either my workshop, the first one of those, or from the Georgian colleagues, we had in the end a little example how to do the input, and that's what we basically want to do together today. So, but quick start into the in what we're doing today, and also a bit of the background. I hope most of you or all of you are familiar now with the resolution 354. That is the background and the foundation of the calculation we're having here. By the way, for those who should not have the software yet, it can be downloaded under the web page geecb.ge. You have to register there and can download then the software and follow the steps together with me through. So the resolution 354 on the minimum energy requirements of buildings was put into force last year, June 30th, 22. And the enforcement was postponed by 1 year, but it will finally enter into force by 1st of July this year. So basically 10 more days until that resolution is active and has to be fulfilled. So it deals with the minimum energy performance requirements for buildings or elements of buildings, and therefore mainly with the U values, so the heat transmission of the building fabric or the building membrane, however you want to call that. Quickly, how does that work? So the architect or the building developer does do the data entry into the software GEECB, the Georgian Energy Efficiency Certification of Building, and out of there, a declaration of conformity with the resolution 354 will be produced, and that resolution is uploaded to a database. And once it's uploaded, it gets a registration code, and you get a PDF file with that, which you have to sign either by pen or digitally. And that will be part of the documents for obtaining a building permit. So it is going to be one of the required documents that you have such a declaration of conformity together with your building permit documentation and documents, yeah. And that declaration must be then uploaded together with the rest of the documents within the application process for obtaining a building permit, and it is for new buildings and for major retrofits. So, and once it's uploaded, it also will be checked by the authorities or the municipalities if there is such a declaration also existing in the database. In the database, there will be stored the unsigned version of the declaration, but also the calculation file, so that in the process of quality control, also the assessor and also the municipalities can actually also look at the calculation file you use to produce such a declaration of conformity with Resolution 354, stating that you fulfilled you fulfilled the minimum energy performance requirements for buildings. That's how it's gonna look. Out of the software, there will be created a PDF. The PDF file is that declaration of conformity. And as you can see here, it has such an identifier. That means that declaration in that way came out of the database or is stored in the database. And actually then the municipality will take that identifying code and see if there's a corresponding declaration also existing in the database. And if so, then that step is done. And also, as only approved documents can actually enter into the database, therefore it is also automatically, at the moment at least, stated that that building or that building permit fulfilled the requirements for the declaration, for the Resolution 354. So, and it is not only for new buildings, but also for major retrofits of buildings or reconstructions. And it also has multiple purposes, like during operation maintenance, you can do such a check with the minimum energy performance requirements. And of course, during the planning, preliminary design of new buildings or significant reconstructions. And there's also something that you should start in your obtaining or considering in your planning process to do that preliminary design or such a first estimation of the minimum energy performance requirements if they are kept. But actually, in the end, you will only pass the final document together with the rest of the with the documents of the building permit for the building permit, and only the final version will then actually be uploaded in the database. So that was also a question in the previous sessions, how to do or deal with the planning process here. So the idea is only once you finish the planning process and are ready for obtaining a building permit, then you would actually do the upload in the database. And that is what we're gonna do today. So for that, we are looking at a quite simple building. It's a squarish building. It is a university building, Faculty of Architecture, and we're gonna evaluate that building together. So we're not only gonna do the data entry into the program, but also gonna tell a bit how to calculate area sizes, how to get to the data you need for the program. But before we go there and do the calculation together, let's quickly look at the program. Hope everyone, all of you have seen it by now. As I'm speaking English, of course, we're looking at the English version. We also have a translation into Georgian. That probably needs to be improved, the Georgian in the one or other area, but also on the last update, we did some significant improvement of the language there. So what we have here is the part for the minimum energy performance requirement check with Resolution 354. The program itself is capable of way more calculations, also of the technical systems, as it will also be later used for the energy performance certificates. But as they are still a bit down the road, we are now focusing on the minimum energy performance requirements, but it will be also later then used for the energy performance certificate. Energy performance certificate, basically the idea is that you do a check after the building is constructed or built, and more or less do a check if the minimum energy requirements are still kept, and also there will be an energy class comparable to the white goods label on fridges, A to F or E or whatever, where you can, which says something about the, let's say the energy quality of a building. The reason why you do both, once the calculation for the building permit and later for the energy performance requirement, for the energy performance certificate, is of course detailed planning. We all know detailed planning can change something in the building, but it still has to make sure that while that detailed planning is happening, the minimum energy performance requirements are still kept. If there are changes due to materials, you use other materials or have information about later than specific heating system or sunshades or whatever, then the energy performance certificate will do the final check if everything is still according to the minimum energy performance requirements. But again, bit down the road, but you will use the same program later also for calculating the energy performance certificate. Coming back to what we are doing now, declaration of conformity with the minimum energy performance requirements. The program looks a bit simpler, so we have a little navigation, and these are basically all the steps you have to do. Then in the middle, there is the data entry section and some help on the right-hand side. We have first some information about the project data, also about the editors, about the municipality, the building owner, and the architect. We can link some images here. Right now, they're not mandatory to upload or to add images, but again, for your own information, it also could help you. Which plans have you used? Maybe you do some drawings or some calculations, and then you can also add those pictures here that they are saved in that file, as it might be used further down the road. If you want to do then the energy performance certificate, you would basically use probably the same file again and just see what has to be added there for the energy performance certificate. So if you keep a little bit of documentation, that can be very helpful. We then have a little section about the reason why that calculation is done, if it's just an assessment of the planning and the preliminary design, or actually then the submitting for obtaining a construction permit, or then later also you can of course then during the detailed planning can use still the program then always to see if you still comply with the requirements, because again, that will be then issued later and also will be checked eventually then after the building is completed. We have some information about the building, but that is really small here for the minimum energy performance requirements. As in terms of an energy calculation, it is quite simple what we're doing here. We're only looking at the building fabric, the building membrane. So a lot of things are like not visible here. Most of the screens you would see later again if you do the energy performance calculation. So, but only we hit now those parts which are not necessary at that stage now. Of course, if we then talk about the building fabric, the building membrane, we have the constructions, U values, and the constructions is, you could say, the type of wall you're using in your building, and also the next section, the windows, the type of windows that you're principally using or basically using in your building. So you can do here also calculate the U value. It has a lot of materials in here, so you don't have to rely on other sources to calculate the U value. The program does that here for you. We will see later how we come to that calculation of a U value. But you might already ask now, what about square meters and orientations? That is then done here with the building envelope, the building fabric. And that is also not the complete building fabric, but only the so-called heat transferring building fabric, building membrane, meaning the heated and or cooled parts are inside the heated or the heat transferring building membrane. The other parts aren't. Sounds complicated, but let's quickly think about a stilt roof with an unheated attic. So in that case, you would only enter the top floor or top ceiling, basically, which divides then the heated area from the unheated attic, and would not enter parts of the building, parts of the roof that actually are in contact to outside air. They are not part of the heat transmitting area surface. So in that case, you would look at the top floor, at the ceiling to the attic. So, and here you link then the types of walls. So you can see it always is the same type of external wall construction or type we're using here. And then we just link them together with certain orientations and also certain square meters. So that is where we link them together, and they will then be part of the evaluation for the individual U values and also the mean values. And after we have done that, we can go to that part, declaration of conformity. So it basically shows always that declaration of conformity. It has here in that case 14 pages. And the most important page is already the first one. It tells you here that it is approved. But we see here it's still the identifier is missing, which is a sign that that data set is not yet uploaded to the database, which you would do by pushing that button. That would create the final declaration, upload it to the registrar database, and that would be then also the document you have to add, or you have to add to your building permit documents. Coming back to one step back, U values. I'm just quickly showing you that part of the declaration of conformity we are basically talking about and what we're looking at. It's the Article 6 of the Declaration of Conformity. Again, that's the English version. So we are looking at two levels here. We have for the building membrane, first the requirements for building construction element for each of them. And then we look at the whole building membrane. So you can see that for the level 1, we have in total 15 categories of structural elements. That could be an exterior wall for building in contact with outside air, for instance. And then we have for the different climate zones, zone 1, 2, and 3, different requirements, different U values, which have to be kept. So the coldest zone, zone 3, the mountainous area, of course, has to have better, let's call it heat protection, than the coastal area in zone 1, which is basically Batumi. Tbilisi is in zone 2. And so for the different types of structural elements, we have different requirements, which all, of course, have to be kept. We have some additional rules here. But then we have also the level 2, that is what's usually called the average or mean U values. And what you do here is you look at the U values for the walls, for the roofs, for the floors, and the windows and doors, combine them all together and build the area weighted average. And then again, for the different values, you have different values which have to be kept as the average values. And that is basically all that is currently checked for the declaration of conformity. So what do we need to show our conformity or to keep the minimum energy performance requirements is basically we need information about the climate zone, and then we need to have the input for the building fabric, the heat transferring building fabric, and build it up. And then the program does the rest. So it checks all the requirements for level 1. It also does calculate the average U values for level 2 checks. If everything is good, then you're good to go. That's what we're going to do now. So we're looking at that building, which is located in Tbilisi. It is a new building. It is a university building, and it has a basement, a ground floor, and a first floor. That is how the plans look. And at that stage already, you might be wondering what kind of information you will need to do an assessment like that. Basically, you need information about the constructions. Construction is, again, meant how the walls are being built. So with plaster, then you have a structural layer, concrete, hollow blocks, eton blocks, or whatever. And then you have cladding, which all contribute to a heat transmission or to the U value of that construction. And then you need the areas and sizes. So in terms of architectural plannings or drawings, it is always a good idea to have the ground, the ground floors or the floor plans, probably the cross section, and also the I don't know, the side views from all the sides that you see the facades. And then you need some information about how you're going to build up the walls, the windows, the roofs, which you usually have or should have. And then if you do also a cost calculation or estimate for that building, also a lot of information which is required there is also required for the calculation of the U values or the areas. So if you have that already, you just need to collect them or calculate the areas there again, combined with the constructions or the way the constructions are being built up. And then you're basically good to go. So I have here that drawings here. That is an aerial view or side view, how it looks. And you can also see it is a quite simple building to calculate, even simplified a bit more for our training here. And then we have the first information. What we're needing is the constructions. So that could be a cement plaster, a hollow clay block layer, expanded polystyrene, so there's already some insulation, and a cement plaster. But before we go there, we go back to the program and actually start evaluating that building together to really start at the beginning. So when we have started the program, we would just go to start a new project. I have some changes here. So with already the first selection, you can select the minimum energy performance requirement calculations. That is also the calculation for that resolution 354. The other two are then later again for either an energy planning of the building. It is a bit more complicated. It is basically for energy professionals. The first part, minimum energy performance requirements, is what we are looking up now. So again, the program starts up very similar to what we have seen before, but now, of course, everything is empty. We have all the screens empty again. And also, before I start now entering the data, I want to go directly to that declaration of conformity. So what you can see now here is that we have so-called validation or errors in obtaining the data from the calculation. So it says now that a lot of information is missing. That information right now is only contact data and basic information about the building. But in order to later upload the declaration to the database, we need to make sure that certain information, contact data, but also, of course, then the minimum energy performance requirements are actually kept. All that is checked in that declaration thing, in that status thing here, and it tells us already now that we have to fill in some data. So that is also later we can use that window then to actually do a little energy planning of the construction to see if the U values are good enough or if we probably have to add some insulation or not. That is so that is an important thing to always look at. Right now, we miss a lot of information about our building itself. So let's go back and start filling the data in. Project data is the very first screen, so you have to give some information about the building itself. So today we want to look at the university building. So we just enter that information here. I, of course, don't have the current address here, so I'm just using my home address. Of course, for a specific project, you would enter then the actual address of that building. I'm just entering also the information about the address, postcode, city. I will be also a contact person listed here as a contact person. Why do we need that? In case there are questions later in the quality control procedures or in further checks, there will be not probably at the beginning, but at a certain stage there will be quality control procedures, and also municipalities might want to do a quality control screening. So they, I mentioned it already before, when you upload the PDF file to the database, it also will upload the project file here so that the municipalities actually have access to all the calculation that has been done. And in case that there are any questions regarding the calculation or so on, we already need here contact information in case someone needs to be contacted or some questions wanted to be asked. So I'm just filling in here the address data. Good, that is already the address of the building itself. The next one is the cadastral code. We need definitely the cadastral code. That will be one of the main identifiers for identifying the buildings in the database later. It will be also part of the code or the identifier for that declaration of conformity. But mostly, at least to my understanding, we only have here for the building permit, only the main cadastral code, not for the individual property or apartment on it, only for the property itself. So we also need to enter the cadastral code for the property in the given format. I don't have a cadastral code right now, so I'm just using that test here. Then we have seen earlier already that, and I'm quickly going back to that table here, we have to identify in which climate zone we are. And there are some rules also with the elevation or the height above sea level for a certain settlement. And in order not to, that you have to look that up, there is a list of municipalities, and here's a typo, that must be settlements. In Georgian version, it is already settlements, where we have here a list of all the settlements, and they're only, even in the English version, only in Georgian. And when you click on one of those municipalities, you get a list of all the settlements that are associated to that municipality. You have to select the municipality the building is located in. And then you get already from also from that regulation 354, there's a list of the elevation about sea level, and then it will be added to the appropriate climate zone. So it works like that. There is a climate zone associated basically to the settlement, it's to the municipality itself. It can also change. Unfortunately, I'm not really able to read the municipalities here, so I just have to click around. So whenever you change something, you see the climate zone is changing. And then what we have is if the elevation is above 900 meters, it is also the settlement, the municipality might be located in climate zone 1. The requirements for climate zone 2 apply. So it's not only the climate zone of the municipality itself, it is also the elevation above sea level. And if the settlement is located above 1,500 meters, it is always the coldest climate zone. So that for municipalities which have a great difference in altitude and in height, which also means a different climate, that is also automatically considered here. That was more or less for the background. For you to know, you have to select the settlement out of the list of settlements, and there's also a search panel here, so that when you look for certain municipalities, you can either start typing and see which are offered there, or select one from the list. And then again, you have only the settlements that are then associated with that municipality. Also select there that from that list, and that would then automatically select the climate zone for you. We can now start with the building owner and the architect. Again, we can type that in, but there's also a little address data management included. So especially for your own company, if you do a lot of assessments here, it might be worth to add your address data in the address data management. Once you have done that, you can just say here, apply address, and it fills in all the data here for that are required here from that address management. So you see two things here. First of all, we have entered everything. Then I'm owner of a building. I'm also the architect, and I'm also the responsible person apparently for that. But we see another thing. If we go to the declaration of conformity, you see now all the validation messages right now have disappeared. And we have entered from that point of view all the necessary information for the declaration. And it will be also listed later here. You can see all the information is then given again here with that PDF later. So you might want to ask why we haven't done any constructions or areas in here. Why is it valid? It works that it checks if there are no construction elements or parts of the building envelope that exceed allowed U values. As we don't have any constructions in there yet, nothing is exceeding that. So that's why there is no more validation messages here. So then we go to the next part. We can enter here some project images for documentation purposes. So you can just go to that add picture and then add some of the data, which are some of the pictures which are also used to do the calculation. We then come to that next part. We want to submit or we want to create a declaration to submit the documents to obtain a construction permit. So that is the right choice here. The same could go for an innovation permit. If you check the compliance and the assessed planning, there should not be an upload to the database. But it will also say in that declaration in the printout, which you can also print out in a preliminary version, and discuss that with building owners or whoever that need to be discussed with, and see where that the minimum energy performance requirements are either kept or something has still to be changed. We have also the possibility, or the regulation allows that there are some parts of some buildings which do not fall under the regulation itself. So, for instance, for temporary buildings or places of worship, in the next version, all that is even hidden here, because if you do have a building that is excluded from the declaration of conformity, you will still get the declaration itself and it will be approved, but it will only list the project data, so the address information, and it will give here the reason why it's excluded from the declaration, or from keeping the minimum energy performance requirements, and that is already the end of the document. So there is no other pages, no listing of maximum U values and so on. So it only has basically the 2 chapters. It is 5 pages long, and if you would go back to let's say the full version, no exclusions apply, then we can already see it has a lot more chapters here, and it is also way more pages, which then have to be filled out. So basically, if you have one of those buildings which that's excluded from the application, you don't have to fill out anything. And again, in the next version, that even will be hidden there, then that is an easy task to do for such a building. But of course, we want to do a full calculation. So before we now come to the construction itself, we have one last stage, some information about the building. 2 things here only: the name of the building and if it's an existing building. So if it applies for retrofit or reconstruction. We have here we can just give it a name like faculty of RP. And then we have the building category here. I already heard also questions about there's only one main category listed, and that's exactly how that should work. So the main purpose of the building should be stated here with the building category. So even if you have mixed buildings, look at what is the major use or purpose of the building and select the appropriate building category. If it's exactly 50%, choose one. But in our case, it's quite clear it is a building of an educational institution. That does not directly apply to any change requirements. That is more or less for statistical purposes at the end, and also reporting requirements from the state of Georgia to European Union Energy Community and so on. Good. We're here already. The basic data is already, we have that already. So now we come to the constructions. Before we enter the construction, quickly how that works. So that is a list of all the catalogs or categories or typical or types of construction you would use. So it could be the wall types, more or less, to put down. So you can add a construction, and give them some layers, so how they are being built up. You can start here with always from the inside. You have here a materials database, which is already quite extensive here. You can, for instance, now start with a plasterboard or plaster. There are then, if you enter here some keywords, then several materials show up, and you might want to ask, why is there more than one gypsum plaster? That is because they have also the materials are there in different densities. So you would either already have the information which gypsum plaster you want to use there, or you just pick one. Usually the worst case, to be on the safe side, is what you would do in a preliminary planning. You give that a thickness, 2.5 centimeters, for instance, and you can already see that the U value up here changed a bit. Oh, it's 25 centimeters. That is a bit much for a plaster. So at 2.5 centimeters, there is already a U value calculated. Now that, of course, is not a stable calculation, so we can add like the staff, the structural, that is the word I was looking for, the structural component. That could be hollow clay blocks, but it can also be e-tongue blocks, for instance. You just choose one of them, have them with 25 centimeters in there, and now you see you already have a quite good U value here to use that. Again, it was updated here. You can also copy then layers to complete that. We'll see that in a bit in greater detail. Later, and I'm now jumping already to the next part where we actually now link the type of construction, that is the selection of constructions we just entered. We could have here, if you have like already insulated parts, or northern part is looking different than the eastern walls or something like that, you could have here a selection of the types of wall you're using. But exactly here at the building envelope part, you would now link the U value with the area, basically. So you link the construction with, first of all, orientation, and also you can say it's now 200 square meters of that wall in your building. We quickly jump again to the declaration of conformity. You would see now here that the mean U value for walls is exceeded, and also the maximum allowed U value for the new wall we just created, it is exceeded, and that's why we actually come now to the energy planning. It is, of course, different than architectural planning, of course, but also the energy part should and has to be planned and evaluated in the building. So with that information, we know now we have to be a bit better in our construction. So again, we would go back to the constructions and say now, okay, now we go first to the building envelope. It tells us for our climate zone, we have to be below 0.25 watts per square meter in Kelvin. That is the required U value. We're at 0.329 right now, so we need to be a bit better in our construction. So we need to achieve 0.25. So we have now two possibilities. First of all, we can try to just make our construction layer bigger. We're almost there. But I'm not sure if we want to have e-tongue blocks with 35 centimeter thickness, but that is one way to achieve the required U value. It's a 0.241 we see now. If we go to the building envelope, we see also now it's not exceeding anymore. And if we go back to the declaration of conformity, no warnings or errors are here, meaning now we would fulfill the requirements of the declaration of conformity. And that is exactly how that program works, or how it should work. So if you have one warning here, then you should and need to be getter. One moment, please. I just heard that Tbilisi might not be in the list. I have to check why that is not here. I tried to do that. I copied it from the declaration of conformity. I will have to check why Tbilisi is not showing up. Good. Let's start with our evaluation here. So we have our building here. And now we're not going with that sample I just showed. We actually look into our documents and we see that it is currently planned to use cement plaster as the inner layer. Then we would use hollow clay blocks as the structural elements, and the EPS already planned for 5 centimeters. Let's see if that is enough, and the cement plaster to finish it off. So basically what we have here is such a construction. The EPS layer is missing, but we call that a solid construction. So that would be consistent layers from inside to outside, different materials and different thickness. So if we enter that, we go back to the program. I'm just quickly deleting what I have done here as a sample. And to do that together now, we would start with add a construction first. So we go to add construction, and then we go to the details of the selected construction and give it a name that can be recognized, external wall, for instance. We go back to the layer selection and we start here. It says here from inner to outer. So to add a layer, we click on add layer. And then we have, again, that material database popping up once we click on that drop-down button. And let me quickly see what we have selected. Cement plaster for 2.5 centimeters as the first layer. So we go here and type in cement or plaster. And again, 3 different densities show up. We just select the first one and give that 2.5 centimeters. And now we have our first layer here. The second was the hollow clay blocks with 20 centimeters. So again, we go here to the materials database and try to find the hollow clay blocks. And you can see I typed in now, not the start word, but clay in that case. Again, we have some clay blocks available here, choosing again the first one, give that 20 centimeters of thickness. U value now is 1.66, so that is what we currently are having. And the next layer was the insulation layer. So now we do it differently. So now we don't use the search panel, but we use the materials database as we have here, but there are a lot of materials in here. So we can use that filter here to only look at insulating materials. And you can see it's still a long list, but it is already a reduced list. So we can also look at different options that we have here for insulating materials. Again, I'm looking for an EPS, and I just take the one with 20 kilograms per square meters and a conductivity of 0.035, which is a typical insulation material, and give it 5 centimeters. And again, just look here while I'm typing. It's now 1.66 as the U value. If we now add 5 centimeters, we are at 0.492. Now we finished that construction with the outer cladding, so to say. Again, it's cement blast at 2.5 centimeters. Oh, that is the same layer as we have at the beginning. And now you can make use of that copy function here. So you just go to that first layer, and there's that duplicate layer button at the end of that. We just hit that, and then we can see that at the end there was the same layer added again. And we have, with that construction, U value 0.489. Good. We have now the construction itself. As we want to start with the facade has two parts. It is not only the opaque areas, it also has window areas. So we will look at a double insulating glass with a PVC frame and PVC spacer as the windows we are using in our little project here. So to enter the windows, we go to the next section, windows here. We click on add window. And then we have a list of various glazings. You can see that is from single glass, from glass brick to even triple insulating glass, or the double insulating glass with one low E. A glass, that is what we're gonna choose. So again, here already a U value is calculated. The U value of the glazing here is also selected. So once we select the material, you see that the U value of the glazing itself changed already, but also the combined U value, which is for the glazing or for the windows, a combination of glazing of the frame and also the spacer itself. The frame, it was PVC. We take the PVC 5-chamber, and also the spacer that is what is between the panes, the window panes or the glass panes. We also take look at PVC spacers here. So with that, we come to a new value of 1.67, which is very fine, which also will be sufficient for our little project. And we can use that later then in the facade entry. So now we have the type of wall we used and also the window we used. Now we need to calculate the actual square meters, how we where that materials are used. And there we have a facade like that. And that's why it's also always good to have such views ready when you do the calculation. So you can see here how the facade is built up. That is theoretically different materials, but we only use one type of construction for the opaque area and one window area. But what we need now is actually the square meters, so to say, from the opaque area and also the square meters from the window area. We can either do that that we calculate the U value, the areas for the windows and walls separately, opaque and transparent areas, or we can look at a facade approach more or less, where we have the whole area of the facade, and the program then actually calculates the net area from the opaque area by subtracting the window area from the whole area. That's now a bit complicated. Let me explain that one more time with that picture here. So what you could do is either calculate the facade. So we would take the height of the building times the length or the width of the building. That is the whole facade area. And then calculate the areas of the windows, enter them together as a facade, and the program then would actually calculate the opaque area, subtract basically the window area from the facade area, and would use that for the calculation. Or we do it differently. If we already, especially if we have a cost calculation and we have an estimate how much the opaque area of the wall would cost, then we have already the net areas. In that case, we would just use the areas of the opaque area and enter that separately and not necessarily link them together. But that is also something then, which is the next slide. So how would you calculate, and what did I do here to calculate the areas? So for the facades, we just can calculate length by height or width by height, which gives the facade area. The roof area is also quite easy. It's the length times the width of the building, which is then the roof area. For the lower completion, we have a strip foundation and floor areas here. In that case, I didn't have enough information in the plan, so I just did an estimate. Thought that the strip foundation is 30% of the area and 70% is the rest of the area. For the windows, you can either calculate the windows and calculate the window height and the window length, or if you have information about the window wall ratio, which you can use here, and that is the approach I described here. The window wall ratio actually describes how much transparent area you have in a facade. So with an estimate window wall ratio, which was on the first slide or second slide of 40%, you can do the same approach here. So height of the building times length of the building times 40%, that gives the window area. And then of course, 60% is then the area of the the other way around. 40% is windows, 60% is opaque area. But to do that, again, you would need and look at your different views of the building. That is something I would recommend to have handy when you do the calculation, that you have all the necessary plans there. But not only the views, also especially in terms of looking at the window area, floor plans can also help. That is the basement. We need that later, that plan for the floor slab area. But here in that floor plan of the ground floor and the first floor, you can also see, I mean, just an estimate, but it is not big enough in that picture, but you can see that the windows are actually 1.25 meters wide, which is then information you can use together with a cross section to calculate actually the areas of the windows. And that is the first floor, again measured, and we use some of the measures then also to calculate the area of the flat roof, for instance. So how do we do that? If we look again at the view of the building and take the information from the floor plan, we can see that, and I rounded up here for our exercise. It is actually a square building, 20 by 20 meters. The height is 8 meters and 40. And the windows have a so-called carcass opening. The carcass opening is before you actually put in the window without the frame. It is really the opening in the building structure, so to say. And our openings, our windows are 1.25 wide and 2.50 meters height, which gives 3 square meters basically per window, and we have 16 windows in total if we calculate or count them here from the floor plan. Again, that is why it's always good to have the plans handy. So with the approach earlier described, we have now the width times the height, that's 20 meters times 8.4 meters, which gives us a facade area of 186 square meters. We calculated the windows by 125 times 2.50 meters, and we counted 16 windows, which gives us a total window area of 52 square meters. So that means in that our little example here, the opaque area would be 116 square meters. So how do we enter that in the program? Going back to the program, and now we go to that building envelope section. The building envelope section, we enter here the wall to outside. We give it a name that could be the wall east. It is a wall to outside or external wall. I'm quickly jumping to that table 3 of the Declaration of Conformity. So that would be considered here the exterior wall for Tbilisi Zone 2. It would be have to be below 0.38 watts per square meter in Kelvin. Let me so we have the wall here, and now we have the list of constructions. We only have the external wall right now, but if you would have more would show up here. And we also see now that it takes the U value, if we remember from the construction, that is exactly the U value from the construction. You also see that we probably have here a problem with the medium U value, but that is for climate zone 3, so I have to change that. We have then here the area. We calculated 168 square meters, and we have the orientation to east. Let me quickly load my sample program, because there it shows already the right climate zone, which I'm obviously not able to find right now. Exactly. So that is the status we just had. We had the external wall. We have the whole facade area of 186 square meters. We have, to correct the orientation here, it's the east wall. And then we have now the options here with the add windows. So we can add a window as a separate element, or that's what we're looking for, the so-called window as part of the facade. If we do that, and we see here's a little parenting, or we software engineer call it parenting, it is associated with the facade east. So you can also see that the window here, the window area is automatically deducted from the area of the facade. So we just have to enter here the 52 square meters of the window openings or the carcass openings. And we can see now we end up here with 116 square meters, which we just saw on the other slide, is exactly what we have for the opaque area of our window. So the program does that calculation for us. So we have now the 52 square meters, the 116 as net area for the opaque part. And now we just have to select the window we entered, and that's it in the calculation. But again, we see here it's marked red. So probably the U value for the facade is a little too high. So if we start here, look here at the maximum U value, it's actually exceeding our actual U value. Also, if we now look at the Declaration of Conformity, it tells us, first of all, that the mean U value for the walls is exceeded, but also the maximum U value for, now it even tells us the facade east, so that's where we have to look for. The facade east, the level 1 check maximum U values is exceeded. We can also look here in the document here that we actually are missing here that check mark that the U value is not exceeded. So we have to do something on or one of the construction elements associated or linked to that line 1 of that table. It is exactly the same wording as in the declaration itself, is exceeding the allowed U value. So we have to be better here. The same goes for the average U values, that is the mean U value for walls. We can also see, of course, it's only one element, so that is the average is exactly the same value that we have. But also here we see that that is exceeded. So what we're going to do now is we go back to the construction side. We already have here an insulation layer, but it's probably not enough. So what happens if we go to 6 centimeters, 0.0303, still not enough. So we probably have to go with 7 centimeters. And what is the value we want to achieve? So even the 6 centimeters would have been enough, but now we see the red mark for that that value is exceeded, is gone. And also in the declaration of conformity, we don't have warnings now listed here. So we see that in the level 1 checks, we don't have any elements exceeding the maximum U value. And the mean U value is below the allowed mean U value, 0.38. So everything is good. So that is now in a state where it actually fulfills the requirements again. And we now just would have to continue to enter our building data. Going back to the prepared data here. So we have calculated the areas, or the area of the one facade. If we now look again at the other views or the other facades, I'm going back here, we see that 3 of the facades look identical, so we just can use the values we just calculated. And we see here, for some reason, the south facade doesn't have walls at all, it just has the door. We come to that later. But for the window area, there is no windows at all. So we can use the same geometric properties more or less for north, east, and west wall, and just use, that is wrong, the 168 square meters without windows for the south facade. So how do we do that in the program? What we can do now, of course, is do the same things that I did, add a new wall at the window, add a new wall at the window, but we can again make use of the copy function here. So we just don't duplicate the window, duplicate 4 times the facade east. So go to the next facade, that would be actually our south facade. So as we duplicated everything, the construction stays the same. Also, the area of the facade stays the same. We just have to change the orientation. You should also then make use of such copy functions to reduce the amount of work to enter such a building. But of course, we don't have windows for the south facade, so I'm just deleting that element. And again, quickly look here then what happens with the cross area and the net area. So now the net area is still 116, which is wrong because there's the window. If we delete it, we can see now the whole facade is as opaque element. We don't have a window, and it calculates now with 168 square meters. East, south, west is the next. West facade, same thing, change the orientation. We go to the north facade. We change that to north. Just quickly check our declaration of conformity. Still, everything is good. So we have now entered the facades of the building. But we have, of course, some more constructions here. So if we look closely at the floor plans, We have here a basement, which is not the same size than the ground floor. So for that little part, we will have walls to the ground. Of course, there's a floor slab in the basement, but then also later, so the other part of the building, in the ground floor. But we have to calculate now also and consider the wall to ground and the floor slab. So again, from our documents, we have here all the materials. It's concrete, EPS, and lime plaster already also on the ground, on the walls to ground. The ground floor now will consist of two types of constructions. That is one, the strip foundation, which is like 60 centimeters of concrete, and the ground floor is very slim, 10 centimeters, more probably usually a bit more, but in that case, it's only 10 centimeters of concrete. So we would have to enter that. And then we have also the flat roof to enter. So what we have then to do next is, if we look at either the floor or the roof, we have to make a new construction, and we're going to do that together in a second. But before we do that, we have to change then the heat flow direction. That is part of the U value calculation, and then you have to tell in which direction the heat flow goes, and that is sometimes a bit confusing, because for vertical wall, the heat flow is horizontal. What? Sounds weird, but it is actually like that. So if we have here the heated area of that vertical wall, the heat is lost, and the heat flow to outside is horizontally through the wall outside. If we have then the ground floor, the heat flow is downwards. So again, we go to enter now first the wall to ground. That is concrete 25 centimeters, EPS 5 centimeters, and lime plaster. We remember, again, we go back to the construction, add construction. We give that name, and I just copy paste it out of here, wall to ground. The name is wall to ground. The heat flow in that case is still horizontal. We start from inner to outside. The outside is, is the lime plaster, and then the EPS. So from inside in that case, because we want to look at the nice plaster, we have here the lime plaster. Again, we use the search function here, select lime plaster, 2.5 centimeters. And then we have the concrete layer. We go to concrete, select one of the concrete systems here, give that 20 centimeters. And then we have the EPS. EPS. Look for the same material, 5 centimeters. We entered now the construction. Let's already go to the building element, the building fabric. We add now it's a lower completion. We give here the name, wall to ground. And now we have to select the type of element. There are several types, wall to ground. We look at, now there's two construction because we just entered that, wall to ground, change the U values. We can also see it is marked in red, so we exceed here the U value again, but let's do it properly. Let's go to the declaration of conformity. Yes, really, it does show that we are now exceeding the maximum U value for the wall to ground. So we go back to our construction section, select the wall to ground, and increase our EPS layer. And now can check that, sorry, I was a bit quick now, that 7 centimeters of EPS is actually enough for the maximum U values. So we have now a U value that is below wall to ground. So we could now also go back because we are now way under the maximum U value. So we could even go back and see what's happening if we look for 6 centimeters. 6 centimeters would also be below 0.5, so we can also live with the 6 centimeters. Again, energy planning might be a little bit ambitious to call it planning, but nevertheless, that's how you would select the thickness of the insulation layer. We see here no red marking, declaration of conformity, all good. So we have the next part, wall to ground covered. Ground floor, again, that is something we split up with a 30% for the strip foundation and the ground floor, or the actual slab, so to say. But before that, again, we go do the construction. So from inside to outside, it is ceramic tiles. Then above the concrete, here's EPS then and a concrete layer. So let's go build that construction. We go back to constructions, add a construction. That is now the name is, I'm going to copy paste that again, ground floor. Ground floor, and here is now important to change the heat flow direction downwards to ground. And then we build up our layers again from inside to outside. You look for ceramic tiles, not glazed, 1.5 centimeters thick. Then we have, jumping again back here, the EPS, 5 centimeters and 10 centimeters of concrete. EPS, 5 centimeters, concrete. Concrete, 10 centimeters. Now, at that time, you might want to ask what's happening if I have a material that I have the properties, but I can't find it in the list. Of course, you can add user-defined materials as well, but then you need to have the so-called rated value of thermal conductivity at a certain moisture level. You have to have also a certification from the manufacturer for the values here, but of course, you can also use user-defined values. Not doing that now because that goes over the scope from that training course now. So if we go back now, we have the ground floor, and now we need the strip foundation. Again, we're going to make use of the duplicate copy function. We have the ground floor as well. The only difference is the thickness of the concrete. So in that case, it will be 60 centimeters. You can also see here, it has already an impact on the U value, the concrete, not as much as a lightweight concrete like Etong or other materials, as concrete does conduct heat better than other materials. But still we have an impact of the 60 centimeters. And now we also need to be clear on the naming. We're going to see that later, because that is now the strip foundation construction, so to say. How do I calculate the area now? So we look at the floor plan. First of all, I haven't shown that. The wall to ground, that is that area here of that floor plan. That is all wall to ground. So I have calculated that to 130 square meters, which we already entered into the program. For the basement itself, we also take that area. It's a square area of for the floor to ground, sorry. It has parts in the basement, 10 by 10 meters, 100 square meters. But of course, we also have from the ground floor that other part of the building. Now you want to maybe want to ask why I did exclude that area here. First of all, that is on the floor. There is the basement below there, so there's something below. And then it goes back again to we only need the so-called heat transferring envelope or building membrane or building fabric. So as the temperature was more or less is the same in the basement part, the heated basement part as in the ground floor. So there's no heat transfer, no significant heat transfer happening. So we don't consider that, and that is not anymore a floor slab, but that is the ceiling of the basement or the floor of the ground floor. So we just do not have to consider that for the declaration of conformity and also the minimum energy performance requirements. That is only actually that part of the ground floor which actually is heat transferring. And as we have 20 by 20 meters, but then we have to subtract 100 square meters from the what is not floor anymore or floor slab anymore, but the ceiling here, we have to subtract that. And then it is on the ground floor level, 300 square meters of ground floor. For the roof later, we are not going to do that straight away. It is 400 square meters then. It is the whole roof area, 20 by 20 square meters. Again, here, how I calculated that, floor to ground. The floor slab in total is 400 square meters, but we said at the beginning, we have 30% of strip foundation, so I just took 30% of the 400 square meters, 120 square meters for the strip foundation, and 70, the rest is with the thinner concrete layer. Again, let's do that in the program. So we have the materials here, ground floor and the strip foundation. We go to the building envelope, we add the lower completion, we call that, I'm going to copy paste that now again. There's that list. Floor slab. And now you see why it's important to name the constructions properly. Now we have the strip foundation here listed, but we are at the rest of the part or rest of the slab part of the building of the floor slab. So that was the 280 square meters here. So again, we select the construction, give it 280 square meters as area. And again, here we see now with the red marking that is exceeding the minimum values. But let's complete the part of the floor. So I copied again. Now doing the strip foundation part that has now a different U value. So I'm selecting that here. And that is the rest of the 400 square meters, the 180 square meters. So again, now we see both are red, so both are exceeding the maximum U values. Also here, the validation part for the declaration tells us that. If we go into the details, we see here now it is line 7, which our elements are exceeding the maximum U values. And of course, also the floor, the average U value for the floor is exceeding the values. So again, we go back and now increase our EPS layer 5, just have it 10 centimeters. Hope that we are now way below the required values. So again, let's quickly check that. The red warning has gone. We would now be able to reduce the 10 centimeters again until we're getting close to the 0.5 U value if we want to do that, or just keep the 10 centimeters. But we are golden here. The declaration of conformities show no validation messages. And that leaves us with the last part, that is the roof. And as a little highlight at the end, let's make a bit more complex or more difficult construction here. So what they have on the roof is those pie parts. Right, I know them as pie roof constructions, where you have those ribs from concrete, and the upper completion there is also solid concrete. We can calculate also U values of those other non-solid layers, also a calculation of a U value or construction like that is possible. That would be now also typical roof construction, especially for single-family houses where you have wooden beams and in between air or hopefully insulation. The same could be for like a workshop or something where you have steel beams and in between some, again, hopefully insulation materials. We can calculate all of that. We can also calculate something like that where only part of the construction is then filled with insulation material. The rest is air. In our example, we have here that construction, but there's plasterboard down there, so it's not visible. We have air trapped in here, so we're gonna calculate that as three layers, and one is that so-called compartmented layer, which I'm gonna do with you now. So for that, we go back to the construction area, give it a name. We have the roof. We again have to be careful about the heat flow. Now it's upwards. And we start again with the inner layer. That is the plasterboard. We select that 2.5 centimeters typically. And now we come to the next layer, which is concrete, air in between, concrete, air in between, and so on, which is that that area, that how that is being built up. So in the program, we again add a new layer. But what we're gonna do now is there's that little yellowish button here, add remove compartment. And when we hit that, I can do it again, hide it, add it again. So now we have the possibility to enter two materials for that one layer. We still have to give it a thickness. It is a quite high, I think with 50 centimeters or 60 centimeters, reduced by the height of the floors of the concrete slab at least at all. So we have here the height of the whole package, and now we have to give the materials for the materials of the studs or rafter. In that case, it would be concrete. That would be the ribs here, and in between is air. So that is exactly how we're going to do that. So that area here is concrete. We select, that was the wrong concrete, we select always that one, 20 centimeters wide. And then for the rest, we have air. Selecting air as a filter, as a material here. And between the ribs, there's 92 centimeters. We see that here from the drawing. So it's 92 centimeters in between. And that is how that construction is built up. So that could be, in our case, it's concrete and air, but that could be for the other case, it could be wood and insulation materials, or it could be two of those layers, one wood with insulation materials and then wood and air as the second part for that other construction I just showed you. In our case, again, we have the ribs and the air, and that is completed by the main part of the roof construction, which is again concrete. And that is that 20 centimeters. So that is now that area up here. We link that again with the building envelope. We have now the upper completion. It is the flat roof. We select the roof material, and that is the 400 square meters from 20 times 20 meters without dimensions, and that is then 400. But we immediately see, oh, that is not enough. We exceed the maximum U value. Again, we see here the red one. We can go to the declaration of conformity. It tells us the flat roof is making a problem here. So we go back to constructions. We go to the roof. We now add a layer, put some insulation on the roof, and as insulation is a protection against heat and cold, we actually put 10 centimeters on top of that. It's also helping to for summer case for cooling. If you have some insulation on the roof there, we see now we have a good U value. Go to the declaration of conformity. No warnings here. Building envelope, we are fine. And with that last step, we actually can hit that button, create a final declaration. It takes a while, and I hope I'm connected to the internet. And it should show us that declaration with the identifier. We already have that identifier, so it already went to the database. It takes a while until the PDF is then showing. That is now coming up. So now it opens a PDF file with our declaration, with all the building envelope elements we just entered, with all the constructions. You can see here it lists the material we entered. And most important for you, it is an approved declaration of conformity, which you can then print out, sign, and upload it together with the rest of your building permit document. And that's basically the end for today. Are there any questions?
Yes, I have. May I ask?
Yeah, sure.
Okay, I wonder, doesn't building orientation matter in terms of window percentage or U factor? It turns out that we should have windows with a value of 1.8 everywhere on the entire perimeter, regardless of the orientation and the area of the openings on the facade. Am I right?
Yes, that is correct. Yes. It is even more important to have a good U value for the windows in terms of heating for the northern part where you don't have solar intake. In terms of heating, solar intake and heat transmission U value counteract itself, but again, for summer heat protection, you want better U values because they also, and also better G values especially, but they go hand in hand with better U values, which reduce the heat load in summertime. But yes, to your question, all orientations, it's the same U value for windows.
And one more. The issues of the isolation be reflected in the program, or should they be reflected at all?
Sorry, you were broken off at the beginning. I couldn't hear the beginning of your question. Could you please repeat?
I'm wondering about thermal bridges. How should the issues of the isolation be reflected in the program, or should they be reflected at all?
With the current stage, the transitional phase of the minimum energy performance requirements, they are not reflected at all. Later, of course, if you calculate primary energy demand or CO2 emissions, and also for the declaration for the energy performance certificate, they make a bigger significance, or better, they are significant. Right now, the declaration, the resolution 354, just says they should be reduced. So there is no additional value for heat bridges or not, but also in terms of a good architectural planning, you would want to reduce thermal bridges also for reducing the risk of mold and so on.
Okay, thanks.
Good. Any other questions?
I have a question. Can I
Sure.
ask?
Yeah, sure.
So you included internal finish also in wall composition,
Yes.
but generally there can be lots of different finishes from inside, and can we just skip the internal finish and make evaluation without it? If it's okay for energy evaluation.
It usually has a minor impact. So, and also at the building permit stage, you also not know exactly usually what materials you actually want to take. So I would also not do the inner cladding like colors or whatever. I included always the plasterboard, and that's where I would finish.
Okay, thanks. One more question.
Sure.
Is there a way to import data without filling it out in the program?
Yes, we're thinking about that, and that will be coming soon, but not until the 1st of July. But there will be an Excel import for the construction elements. Yeah, that will definitely be coming, but probably only during the summer.
Okay, that's great, because we can actually export data in Excel from BIM program.
Yeah.
So if it's properly exported, then we can import this data without filling out everything in the program. Yeah, that would be great.
Yeah.
Thank you.
Yeah, sure. The same goes if you have not BIM data. If you have BIM data, great. But also if you have a financial calculation of like walls and stuff like that, you usually also have information about areas and construction. So that could be also used then in that import. Good. There was a question, how did you choose layer of compartment for roof? I missed that moment and could not find. Yes, let me please quickly show that. It is a bit hidden. That is... Sorry, I need to go back, find my program. That is here with the construction. It is that little button here, that yellow thing. Let me just make a new construction. You add layer, and then that is the add and remove compartment, so you can add and remove it. Finish now. Does that answer the question?
May I ask a question?
Yes, sure.
Regarding local construction materials, such as, for example, pumice, which is very oftenly used for heat for the insulation on the roofs, or, for example, the local plaster, which is very popular and still cheap than other gypsum plaster. So, are those materials included in the list, or could we use these materials during the calculation or not?
They're not yet included, but I got already a list of materials to include. That is also the local. I assume that is the local used materials. They will be included. Other than that, you can always make your own material and reuse that, and that is not then only in that project available, but on that computer for all your other projects as well to use. So if you have a material which is not in the database, you can always add that here with that material data management, and then it will come up if you go there, and I have that material which carries my name again for some reason. It should come up. But it comes up, yeah.
Yeah, we can add material, as I understood, but in terms of the checking if you are uploading this material for, let's say, project licensing and so on. So who will check that those parameters are correct or not?
That will be part of the quality control check, and that is actually something I would suggest that you hand in also a certificate from a manufacturer or from wherever you got the values from, that can be checked then also.
There are no manufacturers. There are, let's say, just mining of those materials somewhere in the suburb of Tbilisi, or I don't know, somewhere in the village.
Yeah.
That's what I'm saying.
Yeah, I understand. But for instance, from that project here, there will be an atlas of building materials. Also, there are several Georgian research institutes which published typical materials. And in that case, I would, and it is included in the atlas of typical building materials from that GOPA project here, which will be soon available. I'm not sure if it's already available, but then you could use the values there, because I mean you need to have an estimate for the thermal conductivity, not an estimate, but a reliable value. So in that case, for instance, go to that atlas of building materials and take a copy out of that. That is, in that case, as good as a certificate.
Thank you very much for your answers.
Sure. Good. Then, if there are there was one more question in the chat. Is there any major difference in making documentation for flat or pointy triangular roofs? No, it is not. You just have to be careful if actually the stilted roof or the pointy roof is part of the heat transferring building fabric, or if it is that attic, and then you would go with the top floor. But other than that, it's no major difference. Good. If you have questions, and also the question will probably come if the presentation and the files will be available. Yes, they will be available, I guess, from tomorrow on our website, where you also will find the contact address for further questions. And other than that, stay tuned for the next series, which will be a even more complex building in the next training session, which also will be announced on the website. And with that, thank you, everyone, and have a good evening.
Thank you.
Thanks. Bye.
Thank you. Bye.
Thank you. Bye.
Thank you very much.
Thank you very much. And
მარტივად მოგიყვები რა გიჩვენია და 70-ლარად არის რაღაც რომელიც არის ინტელკომიდან წამოსახები არის 80-ლარად რომელიც არის პაბლოს რომელიც ჯობია
არა ინტელკომიდან წამოვიდა კაც ფულზე არ არის ლაპარაკი რა იქ აწყობილი მაქვს საქმე პავლოზე ვისგან ვიღებ რა
ინტელკომში
რა ვიცი მიჩვენე ინტელკომიდან წამოვიდა რა
კონდრენ ბარი Agora, Lioca, adivine, isso é
ალო, ლევანი, ხო, დამთავრდა, ეხლა როგორ უნდა ეს უბრალოდ უნდა დავასტოპო იქ ის ორი კნოპკა რო ერთი წითელი მისი სტოპის და ხო, ანუ სადღაც შევინახო რა, ხო. არა ის წავშალე კაცებს, ნამდვილი მათე ხერთი ამბავი რა ერთიან. არ ვიცი. მოკლედ ისა რა ხო, რა ვიცი, რა ქვია, იმას ვქენი დავასტოპე, ხო და მაძლევს ესე იგი გაგრძელების ფუნქციას და ვასპრეზუდენიას და იმას რა, place რა და ხო და ეხლა ეს ხო, ანუ უნდა გადავიდე იმ იმაში რა, იმ პროგრამაში რომელთაც ჩავიწერე, ხო? ხო, export კი. დავაჭირე ამ exports please import media to start crank core project არა. ხო რა, export-ი არა. არა, ეთყობა სადღაც import media. ხო, აი ქვევით ის ორი ღილაკი ხო იყო, ერთი იყო ისა, რა ქვია, სტოპი და მეორე იყო რომ დააწვევი, უნდა გაჩვენოს რა. ხო, გაუშვას ასე ვთქვათ, ხო და მე მინდა რომ შევინახო რა ეს ისა, მაგრამ სად არის ჩორტი ოზნაეთ არავინ იცის. ხო და არა ექსპორტს აქ რო ვაწვევი, არ ვიცი ახლა ვერ გეტყვი რა, მოკლედ წარმოდგენ არა მაქვს. აი ვეყოთ მედია. არა, იქ მე მიწას მიხატავს სამკუთხედს, ანუ დავაწვევი ისევ ჩაწერაზე წავა რა. და გვერდზე არის ხო, აი მაგას უყურებდი ახლა. ხო, new project open, import media, download media, record media არა, ეს ფაილში ესენია რა. Delete progress settings, preference exit არა. ფაილში არ არის, edit ამაში არ იქნება. ანუ ის ფაილი რომელიც ჩაწერა სადღაც ხო უნდა შეენახო, ხო? ხო, შენახულია ხო, მაგრამ სადღაც ხო უნდა გამოჩნდეს ეს შენახული, რა ვიცი, აბა.